In this section, we learn about the function logarithm. If you come across a function like this, then LOG means logarithm function, where A is argument, B is base, and C is value of logarithm of A to the base B. And we can write A is equal to B raised to power C, where A can be any positive value greater than 0 and B can be any positive value greater than 0 except 1. The value of B cannot be 1 because log of A to the base B can be written as log of A by log of B to the any base C, and also log of 1 to the any base is 0. So if B is equal to 1, then log of B will be 0 and denominator will be 0, and if denominator is 0, function becomes not defined, hence base cannot be 1, whereas C can be any real number R. Let's have some example. If log of x to the base 3 is 2, then x will be 3 raised to power 2, that is 9. Similarly, if log of 2x minus 1 to the base half is equal to root 3, then 2x minus 1 is equal to half to the power root 3. If log of mod of x minus 1 to the base 3 is equal to 2, then mod of x minus 1 is 3 raised to power 2, that is 9. So mod of x minus 1 can be plus 9 or minus 9. So x can be 10 or minus 8. Now let's have look at some important formulae. Now, if base b has some power k, then we can write 1 by k multiplied by logarithmic function. Consider the example. Here base is 9. So 9 can be written as 3 square. Now 2 can be taken out and it can be written as half times of logarithmic function. If any number is raised to the log of x, and if it has same base as the number, then we can directly write it as x. For example, 2 raised to the power of log of 7 to the base 2 will be 7. Log of a plus log of b is equal to log of a into b. If base is not written, then we can assume that the base is 10. Log of a minus log of b will be log of a by b. Log of a raised to power n will be n log of a. Log of a to the base b can be written as log of a by log of b to the any base c. Log to the base e is called natural logarithm. So log of x to the base e will be natural logarithm of x or ln of x. Value of e is roughly equal to 2.7. ln of 2 is nothing but the natural logarithm of 2. The values of a and b can be interchanged by taking the reciprocal of the logarithmic function. Logarithm of 1 to the ab base is always 0. If arguments and base have same values, then log will be 1. For example, natural log of e will be 1 because natural log of e is log of e to the base b, and both arguments and base have same values, and the answer will be 1. If log of a is greater than log of c to the base b, then a is greater than c if b belongs to 1 to infinity, but a is less than c if b is fractional, means it belongs to 0 to 1. You can verify this result from the graph on the right side. For example, if log of x is less than log of 3 and base is half, since half lies between 0 to 1, that is fractional, hence x will be greater than 3 and inequality will be reversed. Consider same example, but in this case log of x is greater than log of 3. Here also the inequality will be reversed and x will be less than 3 since half lies between 0 to 1. And we know that argument cannot be negative. It is always greater than 0. Hence the overall solution will be x from 0 to 3. If log of x minus 1 is greater than or equal to 2x plus 3, here base is 3 which is greater than 1, hence inequality will not be reversed here. So x minus 1 will be greater than or equal to 2x plus 3 and we get x less than or equal to minus 4. We also know that the arguments of the logarithm function must be positive, hence x minus 1 must be greater than 0 and 2x plus 3 must be greater than 0, hence we get another two equation. Plot all the three solutions on the number line. Here there is no overlapping between all the three solutions, hence answer will be null set, means no solution. How to solve this expression? Log of mod of x to the base root of 5 is greater than or equal to 2. Mod of x will be greater than or equal to root of 5 raised to power 2. Hence, mod of x will be greater than or equal to 5. And in previous lessons, we have already learned that if mod of x is greater than or equal to 5, then x will be either greater than or equal to 5 or it will be less than or equal to minus 5. Let's plot the solution on the number line. So the solution will be x from minus infinity to minus 5 union 5 to infinity. Consider another example. Here you can notice that the base is fractional and it is between 0 to 1. So the inequality will be reversed here. Hence, mod of 2x minus 1 will be less than or equal to 3 by 4 to the power 3, which gives mod of 2x minus 1 less than or equal to 27 by 64. And we have already learned in previous lesson that if mod of x is less than or equal to any number, then x will lie between minus times of that number to plus times of that number. Now solving this expression will give the values of x and answer, and it is left for you to solve the expression. That's all for this section. Thanks for watching.